Hi everyone. We're going to determine how far a particle travels between the 8th and 10th seconds if the position vector is given here, t squared minus 6 times t. So basically it's a very simple problem, but we're going to go over also one and look at t equals 2 to t equals 4. So we want in between here. So between 8 and 10 seconds and between 2 and 4 seconds. We're going to do both of these for this problem. Alright, so let's do the first one here. And all you do is you take x, since we're doing from 10 to 8 here, we're going to go x of 10 minus x of 8. So when you do that, you're going to get, you plug it in your t squared minus 6t. We're going to plug in 10. So x of 10 equals, it's going to be 100 minus 60. And then x of 8 is going to be 80 minus 48. So what you do is you're going to subtract those. This is going to be equal to 100 minus 60 minus 64 minus 48. And that all equals 24. And that works out well for us. The problem's going to be if we try, like I said before, we want to try between 2 and 4. So we're going to do x of 4 minus x of 2. So 4 is going to give us 4 squared. This is not 80, 64 here. Alright, so put 64 here. Alright, so we're going to do 4 squared is 16 minus 4 times 6 is 24. And then minus, we'll try 2, so we get 2 squared is 4 minus 12. Now what this yields is negative 8 minus a negative 8, which equals 0. And the problem is, this is saying that the particle doesn't travel at all when it's not true. Basically, the particle is traveling between negative 8 and negative 8. It's not just not going a distance. So basically, what you have to do is divide the intervals up. So we have 2 to 4, and it hasn't stood still. To fix it, we're going to divide it up when the velocity is negative and the time when the velocity is positive. So we're going to do the velocity here. So the velocity of t would equal 2t minus 6. Now, the velocity is negative. Let's plug in 3, because 3 is in between 2 and 4. Because we want to divide this up. If we try 3, you get 2 times, we're going to do less than 3. So let's try 2. We're going to look at what's going on around 3. That's dividing these two up. That's 2 plus 4 divided by 2 equals 3. So let's try 2. So you get 2 times 2 minus 6, and that equals negative 4. So that's negative. And let's try 4. If you try 4, you're going to get basically I want to try bigger. So let's try 4. Let's just put 4 in. So you get 2 times 4 minus 6, and that's going to be 2, which is positive. So this is positive, this is negative. So what we're going to do is change our intervals between 3 and 2 and 4 and 3. So we're going to have from 2 to 3, and then we're going to do from 3 to 4. And that's going to give you accurate distance. So we're first going to do absolute, and you have to do absolute value. X of 3 minus X of 2, absolute value. So this is this part. And then you add it to this interval. And that's going to be absolute value of X of 4 minus X of 3. And you plug it back into your original equation, and this is going to equal absolute value of negative 9 plus 8 plus, and this one's going to be negative 8 plus 9, and this is going to be absolute value of negative 1 plus absolute value of 1, which equals 2. So this is the distance the particle traveled, is 2, not 0. So be careful with that one, okay? If you get 0 when you're trying to do the distance, you're going to have to break up the interval. That's it. Thank you. Have a nice day. Bye-bye.